Dear students, in previous class we discussed about a legendary symbol and some of its properties. So what is legendary symbol? Legendary symbol is if n is incongruence to 0 mod p, that means if n is incongruence to 0 mod p, then n by p, the legendary symbol is n by p equals 1 if equals 1 is if n is nrp and minus 1 if n r bar p, means n is nrp and n r bar p. Okay. Now let us discuss about Euler's criterion. What is Euler's criterion? So Euler's criterion means it is let there is a result, let P be an odd prime. P be an odd prime. Let P be an odd prime. Then for all n by p congruence to n power p minus 1 by 2 mod p. So this is Euler's criterion. N by p congruence to n power p minus 1 by 2 mod p for any odd prime p. So how its proof is, that is depends upon the previous result. In the light of Euler formula, we prove that n power p minus 1 by 2 congruence to plus or minus 1 mod p. So here, say n by p is an odd prime, then we have to show that n by p congruence to n power p minus 1 by 2 mod p. For all n, so there are two different cases. First one, if p divides n. P divides n means n congruence to 0 mod p. If p divides n, that is n congruence to 0 mod p, what is the legendary symbol? Then we know that n by p equals 0. Okay. Now again, when n congruence to 0 mod p, that means also n power p minus 1 by 2 also congruence to 0 mod p. Sure? Yes. N power p minus 1 by 2 also congruence to 0 mod p. N power p minus 1 by 2 congruence to 0 mod p means 0 congruence to n power p minus 1 by 2 mod p. Why? Because of the symmetry. But what is 0? That is n by p. That means n by p congruence to n power p minus 1 by 2 mod p. So when n congruence to 0 mod p, surely n by p congruence to n power p minus 1 by 2 mod p. So if p divides n, the result is finished. If p does not divide n, what happens here? When p does not divide n, so there are two cases arises. When n by p equals 1 if n rp and n by p equals minus 1 if n r bar p. Agreed? Now when n by p equals 1, what happens? How to prove this one? When n by p equals 1, first case, means it is n rp. That means, so you consider, since n by p equals 1, that is nrp, means there exists a polynomial congruence or x square congruence to n mod p. The congruence x square, the congruence form x square congruence to n mod p has a solution. Agreed? X square congruence to n mod p has a solution means, that means x square congruence to n mod p means n congruence to x square mod p. N congruence to x square mod p means n power p minus 1 by 2 congruence to x square all power p minus 1 by 2, that is x power p minus 1 mod p. Agreed? N power p minus 1 by 2 congruence to x power p minus 1 mod p, taking p minus 1 by 2 the power. So it is x power p minus 1 mod p. But we know that x power for any odd prime p, x power p minus 1 congruence to 1 mod p. Enough? Therefore, this becomes n power p minus 1 by 2 congruence to 1 mod p. But what is 1? n by p. That means n power p minus 1 by 2 congruence to n by p mod p. Okay. So again by symmetry, we have this gives n by p congruence to n power p minus 1 by 2 mod p. Enough? So when n by p equals 1, the result also quadratic. Now come to the next case, when n by p is minus 1. How? Now consider the second case, when n by p is minus 1. n by p, when n by p is minus 1. So how? n by p is minus 1 means it is actually n r bar p. That is quadratic non-residual n r bar. So we consider a polynomial. Consider a polynomial f of x equals x power p minus 1 by 2 plus 1. Consider this polynomial f of x equals x power p minus 1 by 2, not plus 1, sorry, x power p minus 1 by 2 minus 1. So clear, f of x be a polynomial of degree. What is degree of f of x? Here degree of f of x is nothing but p minus 1 by 2. F of x be a polynomial of degree p minus 1 by 2, then by Lagrange's theorem, f of x congruence to the congruence relation, f of x congruence to 0 mod p has at most p minus 1 by 2 solutions. Agree? So, but these p minus 1 by 2 solutions are quadratic residue solutions. P minus 1 by 2 solutions are quadratic residue mod p. Why? Therefore, we know that the polynomial is, you also prove that when p be an order prime, then every reduced residue system mod p has exactly p minus 1 by 2 quadratic residues and exactly p minus 1 by 2 quadratic non-residues. Here we say that by Lagrange's theorem, the polynomial of degree p minus 1 by 2, then f of x congruence to 0 mod p has at most p minus 1 by 2 solutions. But this p minus 1 by 2 quadratic residue mod p are solutions. Therefore, the non-residues are not solutions. Why these p minus 1 by 2 are quadratic residue solutions? If n rp, what happens? If n rp, what happens? Then we have n power p minus 1 by 2 congruence to n power p minus 1 by 2 congruence to 1 mod p. Okay? Yes. Since they are quadratic residues, n power p minus 1 by 2 congruence to 1 mod p. That means n power p minus 1 by 2 minus 1 congruence to 0 mod p. Okay? Yes. That means n power p minus 1 by 2 minus 1 congruence to 0 mod p means n be the solution of x power p minus 1 by 2 minus 1 congruence to 0 mod p. That means x power p minus 1 by 2 congruence to 1 mod p. So, or x power p minus 1 by 2 minus 1. What is actually x power p minus 1 by 2 minus 1? That is the given polynomial. Therefore, n be the solution of this f of x congruence to 0 mod p. Okay, n be the solution of f of x congruence to 0 mod p. So, these p minus 1 by 2 are quadratic residue mod p solutions. Therefore, the quadratic non-residues are not solutions. Agree? Now, so if n by p is minus 1, given n by p is minus 1, means it is n r bar p. Then n by p, we know that if n by p equals 1, p minus 1 by 2 are quadratic residue solutions. Therefore, n power p minus 1 by 2 congruence to 1 mod p. Since n by p is minus 1, when r bar p it is not a solution, then we have n power p minus 1 by 2 is incongruence to minus 1 mod p. Agreed? Okay. That means n power p minus 1 by 2, n power p minus 1 by 2 plus 1 is incongruence to 0 mod p. Agreed. But we know that by using Euler theorem, we prove that n power p minus 1 by 2 congruence to plus or minus 1 mod p. Agreed. We already proved this result. For any n power p minus 1 by 2 congruence to plus or minus 1 mod p. But here n power p minus 1 by 2 is incongruence to minus 1 mod p. So from there n power p minus 1 by 2 is congruence to 1 mod p. Agreed. N power p minus 1 by 2 is congruence to plus or minus 1 mod p. It is n power p minus 1 by 2 is congruence to minus 1 mod p. So n power p minus 1 by 2 congruence to minus 1 mod p means n power p minus 1 by 2 is congruence to what is minus 1? It is n by p mod p. What is n by p? So by the symmetry, it is n by p congruence to n power p minus 1 by 2 mod p. So that's what we requires here. Agree? Okay. It is n power p minus, since n by p is minus 1, we have that is n r bar p. Therefore n power p minus 1 to 1 by 2 is incongruence to 0 mod p. That is n power p minus 1 by 2 minus 1 is incongruence to 0 mod p. So but we have n power p minus 1 by 2 is congruence to plus or minus 1 mod p. This is from Euler theorem. Therefore n power p minus 1 by 2 is incongruence to 1 mod p. So from this argument, n power p minus 1 by 2 is congruence to minus 1 mod p. But actually what is minus 1? That is n by p. So n power p minus 1 by 2 congruence to n by p mod p. That is by symmetry, n by p congruence to n power p minus 1 by 2 mod. So for every n and for any order prime p, we prove that n by p congruence to n power p minus 1 by 2 mod p. Agreed. That is true for every n. When p divides n, it is immediate. When p does not divide n, then it is the proof is done by using the result n power p minus 1 by 2 congruence to plus or minus 1 mod p and so on. Okay. Right. Now, what about the multiplicity of this legendary symbol? That's our next discussion. What is the multiplicity? A function of f is said to be multiplicative if f of mn equals, function f is said to be multiplicative if f of mn equals f of m into f of n when m and n are relatively primes. Then it is true for every m and n, f of mn equals f of m into f of n, that is true for every m and n, then the function is said to be completely multiplicative. Agreed. What about the multiplicity or complete multiplicity of this legendary symbol? So, consider if p divides m or p divides n. Suppose p divides m or p divides n. When p divides m or p divides n, surely p divides mn. Okay, p divides mn. P divides mn means mn congruence to 0 mod p. So by legendary symbol, when n congruence to 0 mod p means when p divides n, that is n congruence to 0 mod p, then n by p equals 0. So here mn by p equal, by legendary symbol, mn by p equals 0. Okay. Yes. But when p divides m or p divides n, p divides m means m by p equals 0. Enough? P divides n means n by p equals 0. Agreed. So mn by p equals 0. Mn by p equals 0 means what is 0? 0 is m by p into n by p. So when p divides m or p divides n, then mn by p equals m by p into n by p. Hence it is completely multiplicative. Okay? Yes. So first part is immediate. First case is immediate. Suppose p does not divide m. Comes the second case. If p does not divide m and p does not divide n. If p does not divide m and p does not divide n, what happens here? P does not divide m means that is m is incongruence to 0 mod p. and n is also incongruence to 0 mod p. Okay. Now m is incongruence to, that is m incongruence to 0 mod p and n incongruence to 0 mod p. Enough. But by the previous argument, for every n, we know that n by p is congruence to, for every n, we have n by p is congruence to n power p minus 1 by 2 mod p. Agree? So according to this argument, we have for mn by p, what is mn by p? Mn by p is congruence to mn power p minus 1 by 2 mod p. Okay? Yes. For any n and for any order prime p, we already proved this result. N by p is congruence to n power p minus 1 by 2 mod p. So in the light of this argument, mn by p is also congruence to mn power p minus 1 by 2 mod p. Okay. Mn power p minus 1 by 2 mod p means there is mn by p congruence to, it is m power p minus 1 by 2 into n power p minus 1 by 2 mod p. Okay. Yes. So mn by p congruence to m by p, that means mn by p congruence to m power p minus 1 by 2 mod p. What is m power p minus 1 by 2 mod p? That is m by p. So it is m by p into n by p mod p. Okay. M by p into n by p mod p. Clear? That means p divides this mn by p minus of this m by p into n by p, minus of m by p into n by p. Okay. What is p? P be an order prime, and we saw that, p be an order prime, and we know that m by p is, what is m by p? M by p is plus or minus 1, n by p is plus or minus 1, also mn by p is also so. Agreed. Since p be an order prime, here mn by p is plus or minus 1, m by p is plus or minus 1, and n by p is plus or minus 1. Hence the difference, therefore the difference mn by p minus of m by p into n by p is either 0. Okay, either 0 or 2 or minus 2. Either 0 or 2 or minus 2. Plus 2 or minus 2. But what is p? Since p be an order prime, and p divides this mn by p minus of m by p into n by p, then there is only one possibility: the difference should be 0. Why? Because p is an order prime and p divides this mn by p minus m by p into n by p, then the difference should be 0. Difference should be 0 means this mn by p minus of m by p into n by p is 0. That is mn by p equals m by p into n by p. This is true for every m and n. Hence the legendary symbol is completely multiplicated. When p divides mn or p divides n, the result is immediate. If m and n are not the multiples of p does not divide m and p does not divide n, then as we prove that mn by p is m by p into n by p, with the help of a crucial point, for every n and for every order prime p, n by p congruence to n power p minus 1 by 2 mod p. Agreed? Okay. Now, so when p divides n, what happens? P divides n means when p divides n, that is n is a multiple of p, n by p is 0. So the legendary symbol vanishes when p divides n. Hence, yes. So the n by p is also called quadratic character mod p. The legendary symbol n by p is also called quadratic. It is quadratic character mod. Okay. Now by using these properties of n by p, we try to evaluate minus 1 by p, minus 1 by p and 2 by p. That is our next task. evaluate the evaluation of minus 1 by p and 2 by p is our next class. Agreed. So these are the important properties of this legendary symbol. If n is complements to 0 mod p, n by p equals 0. If n is in complements to 0 mod p, n by p is 1 when it is quadratic residues, and it is minus 1 when it is quadratic, when n is quadratic non-residues. Also, by Euler theorem, by the help of Euler theorem, we prove that n power p minus 1 by 2 complements to plus or minus 1 mod p, and by using that result, we also prove an important result. For any n and for any order prime p, n by p is complements to n power p minus 1 by 2 mod p. Agreed. With the help of these results, we also prove that the legendary symbol is completely multiplicative. That is, for every m and n, mn by p is m by p into n by p. Okay.